Welcome to the latest edition of the IoT Leaders podcast with me, your host, Nick Earle, the CEO of IoT company SI. IoT Leaders is the podcast that attempts to demystify the intriguing, the exciting, but often baffling world of IoT. And this week, I'm delighted to welcome Peter Doggart, who is the Chief Strategy Officer for Armis, and we're going to talk about all things security in the area of IoT. So, Peter, welcome to the IoT Leaders podcast.
Thanks, Nick. Great to be here.
Okay, and I think we've got some really cool stuff to talk about. The world of security is full of horror stories and opportunities and intrigue. Let me put it that way. But first of all, let's talk about Armis. And Armis is a pretty hot company. I mean, I know that you guys have doubled your valuation in a year. I'm insanely jealous. You're a $2 billion valuation company. And you're a pretty unique security company as well in what you do and the way you do it. So just give the listeners a little overview of Armis before we dive in.
Yeah, would love to. And really, this goes back to one of my passions, and that is trying to figure out how we go see and secure every single asset on this planet. And fundamentally, that's why Armis was created, was to
a fairly modest mission statement.
It was try and protect all these new devices. And the reason I kind of landed here was, again, it's a passion of mine, and it's probably one of the largest cybersecurity problems we will face this decade, and probably into next decade as well. It's really centered around all these new devices coming onto our networks, and fundamentally thinking about their risk to the business and their potential consequences and impact to the business. And we certainly believe that this influx of new devices, these new connected devices, are going to cause and are causing massive operational headaches for almost any business.
Yeah, for those of us who aren't directly involved in the security, internet security, cybersecurity area on a day-to-day basis, I guess the time we kind of take it for granted. We don't think about it, which we'll get onto because that's part of the problem. People don't think about it, except for the bad guys. But but every now and then you get these incredible public horror stories. I mean, I'm thinking just recently, since the time when we spoke about a week ago to prepare for this podcast, and now, I mean, we've had the American pipeline example of a pipeline.
That's right, pipeline, we have JBS. We've almost every day now we're seeing attacks.
Yeah, and I guess you're monitor as a company. Do you monitor those attacks? Can you actually see that the momentum is increasing?
Yeah, I mean, this impacts impacts every industry, from financial to manufacturing to oil and gas, utilities. And we are currently tracking over 1 billion IoT devices, or just assets, we call them. And over the course of the next 4 years, we have seen and extrapolated out through our research we'll likely have about 56 billion devices by 2025 connected. And that's an astonishing amount of devices.
That's an astonishing number of potential breach points to an enterprise. And I mentioned at the beginning that you do this in a different way. I mean, I know you worked for Symantec for many years, and you ran a lot of the partner program, a lot of the biz dev functions. But traditionally, the way, at least which I understand it, we've tried to catch this ball that's bouncing down the stairs, if you like, is to try and put some software on a device. I mean, your phone has a bit of software in it, your corporate version of your phone, your corporate version of your laptop. Armis didn't take that approach, did you?
No, and this comes down to a fundamental fact about these devices. And it's also important to understand what's happening? Why are we seeing 56 billion devices coming onto our networks in the first place? And part of the reason for this is we are seeing this pervasiveness because they are super low cost in the first place. We've got bandwidth galore everywhere. We've got low latency now, obviously with the work you're doing, Nick, on the cellular side with millimeter wave technologies. And it's just very, very easy to go and pick up these devices, off-the-shelf hardware, off-the-shelf software, package it all together. But here's the problem. The numbers of permutations out there are vast. And it's impossible to put a security agent, what we call in the business, onto these devices. It's just practically impossible. I think we're tracking on the order of 15 million different permutations of devices out there. So just think about being a software security company having to design and maintain 15 million different versions of an agent, and somehow working with thousands of manufacturers to get that software onto those devices. It doesn't work.
It's an unsolvable problem, and so I guess, just so our listeners understand, I think what you're referring to is you have an increasing number of devices, trackers, but you also have different software on those devices, and they can be all configured differently as well.
That's right.
And so the number of permutations, that if you're going to then identify a problem, issue a patch, test the patch, distribute the patch, install the patch, the number of permutations that you have to go through is an exponential problem. And you're using a linear, if you're trying to put software on it, I guess the way I would describe it is, we're using linear processes. Here's a patch for that device. Well, it doesn't work on this device because it's different software, or it's configured slightly differently. We're using a linear solution essentially to solve an exponential problem. In other words, you can't keep up.
No, and the old way of trying to solve for this problem just doesn't work anymore. And in fact, it's becoming less relevant. The ratio of what we call these managed devices, like the laptops we're on right now, Nick, we've pretty much solved for that with security agents from people like Spike and Windows.
But they're not like IoT devices. They're pretty.
No,
they're tightly coupled hardware and software, as is your phone. But IoT devices are not like that, are they?
No. And the only way to solve for that is an agentless approach. It's basically looking at the world from a networking perspective. And we can talk more about that a little bit later, but it's Armis pioneered this approach about 5 years ago to take a wholly different approach to security. And that is one of the world we're moving to in security has to be agentless in order to scale. We cannot think of this in the old world. So it has to be cloud, and it has to be agentless.
So let's double click on this, because we're now getting down to the hub of the approach, which, as you say, will ultimately become into the issue of who has visibility of the network. But before we get onto that, so the ball bouncing down the stairs, all the device configurations, the number of devices that are being adopted, you're trying to put a piece of software on, the companies just can't do it fast enough. In fact, it's getting to the point where it's getting less and less relevant every day, point you're making. So therefore, the paradigm shift is agentless, which basically, in case there's anyone who doesn't know what that means, it means you don't put a piece of software on the end user device. You actually have central control, central policy deployed automatically to everything that's connected without having to put some code in all of those things. That's which right. I guess means that one of the first challenges you've got is identifying all these devices. Is that where Armis starts?
Yeah, absolutely. And I would say a good strategy, a good security strategy always starts with visibility. You fundamentally have to understand what's on the network, what's in your domain, and what's entering your network. And here's the scary thing. many organizations around the globe do not understand what's on their network.
Yeah,
and it's getting worse.
I'm sure they have no idea. I'm sure you must find customers who you ask them in advance and then you say, well, actually, we'll put like a sniffer on or whatever, the technology that you use to identify them. And the two are completely different, right?
Yeah, there are so many occasions where we walk into a client's environment and we just spin up Armis within a few minutes, and where the client thinks they've got 150,000 assets or IP addresses or whatever on the network, we go, no, you've got 700,000.
Wow.
And the little light bulb goes off. And this is,
I can imagine a lot of things go off at that point.
It's quite
really. I mean, they can be that far apart.
I mean, I was a very interesting case, but many are at least double, 40% more.
Yeah,
and it just goes to the point we've let this attrit so much, and the technologies have not been employed, and the maturity has not kept up with IT and security at the pace of the innovation of these devices. So you've got this gap forming that has become so large, it's opening up this wound for cyber attacks. And as you noted, Nick, earlier, we are seeing countless attacks almost on a daily, weekly basis now, very large ransomware attacks.
You know, I got this picture in my mind as you were speaking, Peter, of saying to someone, is your house secure? And say, yeah, I'd locked all the windows. And you say to the doors, you say, well, how many have you got? Well, I've got, 25 windows and 4 doors. And you say, well, that's kind of interesting because I just walked around your house and you've got 100 windows and 9 doors. Have I? I mean, really? But actually, it's a little bit worse. Is that there are people adding new windows all the time.
It's actually worse than that.
Okay.
There's you can take the analogy one step further. There's more windows being added, but there's different variety from different manufacturers of windows being added. And the guys who are making the locks, well, they're not so good.
Yeah.
And they're exploitable. And that's what we're seeing is the numbers are growing vastly up, but also the vulnerabilities or the exploits of these devices are increasing. Armis, over the past numbers of years, have released countless vulnerability releases. Urgent 11 was one we released about 1.5 years ago. And this one was quite staggering. This was just as I was joining the Armis organization. And Urgent 11, basically, for those who don't know, is 11 vulnerabilities in some of the largest operating systems that reside in these IoT devices. And those devices are things like firewalls, medical devices, operational technology sensors, manufacturing equipment, all running these operating systems from VxWorks, Nucleus, ThreadX, ZebOS, the list goes on. And using the window analogy, it allows the attacker to basically pick that lock within about 2 seconds and come in. So it's not only the number of potential ways to get in, but frankly, the security is very, very poor with these devices.
So my understanding is, so you use Agentless, so you identify the windows and the doors, the openings. You haven't solved the problem yet. You then profile all the devices. So you then build up a sort of databases of this is what you've got, by the way, by type of device. And then I think you go into, you look at the network data. And now we're getting into the solution that we're coming up to for cellular devices, which is what this is all about, which is cellular. But before we get to that, you actually look at the behavior and the patterns of what's happening on those devices. So you can start to build up profiles of anomaly detection, behavior, et cetera, et cetera.
The system
is not normal.
Yeah, exactly. The system works, if you're familiar with Tesla and their self-driving software, what they're doing is very similar to what we've been doing on the devices. It's really taking vast quantities of data in, understanding what these devices are doing within context of their environment. So we're seeing tens of thousands, hundreds of thousands, millions of times of a device on a network, and understanding how that device is interoperating, how it's communicating, what does it look like, what's the normal behavior in a medical context, in a manufacturing context.
Yes. Yeah.
And only by getting this sort of vast quantity of data in a machine learning, we have both unsupervised and supervised machine learning in the back end, can you get to the point at scale where you can, at high efficacy, fingerprint these devices, and as you say, Nick, down to operating system versions, what protocols they're using, what applications they're running, down to, if you look at PLCs in the manufacturing lines, we can actually see inside the cards, the modules, and see what messages each module and the commands to those modules. So you can start to gather an amazing richness of data agentlessly, in a very passive sense.
No human could ever do. So I get it, right? But as always, the ball keeps bouncing down the stairs, and the attackers get smarter and smarter, and there's a whole class of devices that you can't see, right? As the two companies, Armis and SI, we have done a joint announcement, a solution, joint security solution. We're going to talk about that in a second here. But cellular connected devices in particular, you can't currently have visibility of. You can't see them. That's right, isn't it? Because they're not connected to the enterprise network. They're connected to somebody else's network, the mobile network operators. So that's a problem.
Yeah, that's right. And the whole nature of Armis is it's passive. We don't actively scan, as you noted, we don't have agents. So we have to look at the traffic. We have to inspect on the wire, which is good because you get to the source of truth. But you need to have access to that traffic. Yeah. And to your point on the cellular side, I don't know how many MNOs there are in the world now. There's
about 820 something according to the GSMA.
Yeah, exactly. So you've got lots of MNOs out there, and traffic is being dispersed everywhere across loads of different MNOs. How the heck do you get that data in a cohesive fashion? It's really,
you don't have the network connection. You just receive the data, which might have an attack inside it, but you can't look at the net flow data. You can't analyze the data. So what we've, just to help the listeners, what we've announced is, now that everyone's got a good understanding of what Armis do, as those regular listeners of our podcast will know, what we do as SI is that we actually run our own private network, and we actually federate the world's MNOs together into a private network, APN access, don't use the public internet. We become the single eye of the needle, where we manage the connection, we do the billing, we do the device management, we do the support, et cetera, But basically, with a single SIM, we are actually providing localization, not just roaming, but localization and roaming across those 820 networks, delivering 99% global connectivity. And so of course, the spark that caused us to talk was, you were saying, well, we've got this great business, which the financial markets love, not surprisingly, given the problem that you're solving. But actually, there's a bigger percentage of devices that are invisible to us because the edge is growing faster than the number of the devices. Laptops, printers, PLCs aren't growing anywhere near the rate of IoT devices. And with 5G coming along, I mean, people talking about 5G is a better version of Wi-Fi. More and more devices are going to be cellular connected, which means the percentage of the estate that Armis can see is in danger of declining with our solution, because every device, regardless of which MNO it is connecting to, every device goes through our network. We're an eye of the needle for all the traffic, and so the collaboration that we've announced is that with an interconnect between an API interconnect between Armis and SI, the Armis functionality is then enabled across cellular networks. And that was the genesis, wasn't it, of why this would be a good idea. If we enabled you to see cellular connected devices across any MNO, it would be good for your business, and it would be good for us, because what we're saying is this is the value of having a private network, not sending stuff over the internet, which we talk about the MNOs, but a lot of MVNOs say, oh, we solve this problem, we aggregate it, but they solve it by actually sending data over the internet. They're not managing the network, whereas we run a private network. Therefore, we can give you that net flow information. And so therefore, you can actually run Armis on all the devices that you talked about, plus the devices that are cellular connected through MNOs. And that's the genesis of the cooperation, isn't it?
Yeah, no, I love this combination. And for the very first time, an enterprise can now see all their assets, be it if they're on their corporate network, the devices at home, in the cloud, on Wi-Fi, and now cellular. So going back to our earlier statements, it's all about visibility. It's all about the assets. Where are the assets? Am I getting to a single source of truth of understanding where my assets are and what they're doing? And this combination allows us to go do that and clean up the age-old problem of cleaning up the CMDBs, the configuration management databases, which power, frankly, operations of any big company. And I love what you guys are doing, because it's providing very secure connectivity reliably, and now we're overlaying the sort of asset visibility and security of the devices. And it allows, I think it allows businesses to innovate as well. Because at the end of the day, this is what it's all about, is you can go to one of these energy companies, Exxon or BP or Shell, rolling out these EV chargers. And now we can have secure, reliable connectivity constantly and know what's going on with every single EV charger in their estate, and map it back to their management systems and other systems in their own estate. So it truly is an industry first. And so excited about what this business can go and do now with this, now reliable and secure connectivity.
We're just about to release a bit of market research in the next few weeks. My marketing manager will kill me for saying this, but I'll pre-announce it because I can. Market research about what are the inhibitors, the famous 50 billion things that are going to connect it. We talked about it a lot in these podcasts. We only got to 11 billion things by 2020, not 50 billion. What were the inhibitors? And there's a ton of them, but number one of every list is security. And so we've been saying, well, that's why, you need a APN-based access, encrypted tunnels, private, don't use the internet, the whole SIM, security certificate being stored inside the SIM. But actually what this adds is that you then can have central policy definition with automatic deployment to the edge. Because what you do is bring the policy, and the policy can then be dynamically applied to cellular connected devices. Now that, if you're a CISO, a chief information security officer, says, well, I'll let these devices be connected to my network, but I damn well need to be sure that my policy, you talk about the configuration management, it could be a configuration policy, compliance policy, which IP addresses, DNS addresses can they access. That my policy I want to define centrally and have auto deployed to the edge. But if you can actually define central policy and have it apply to everything that's connected to your network, and things that are sending you data that aren't directly connected to your network, then from a CISO point of view, you start saying, okay, then in which case I'll trust the system, because people lose their jobs. They don't just lose their jobs. The companies can go out of business. I mean, pretty quickly, as we know from some of these security hacks that we're seeing. So that's the basic premise, and we're going to be rolling that out with pilots and things. And of course, anyone who's listening, they know which companies they can contact. But I wanted to just pivot now and just talk about the bad actors, the bad guys, because so far what we've been doing is talking about the good guys are doing. But the bad guys never sleep, it seems. And it seems to me, Peter, that when you hear about really sophisticated security hacks, you think, wow, that was really, really clever. But in the area, and they really are had to have a lot of knowledge to be able to get into that system. But actually, in the world of IoT, it seems like, it's not just the number of windows. It seems like we have an active policy of flinging the windows open and almost inviting people in, because these devices, they're not secure to begin with. I mean, they're really very unsecure, aren't they?
It really is. I mean, we are seeing literally people pick up these devices which have default passwords built into them or backdoors. Yeah. And you may think, oh, no, that doesn't happen. Oh, no, it does. And it's happening at an alarming rate because it's not at the forefront of people's minds as they are designing these devices. They're at the end of the supply chain. So they're picking up hardware components that have been developed by another manufacturer.
Yeah, they're in a rush to get it out.
From chip manufacturers way back when. And you can get the really simple attacks going, okay, we're going to try the easy vulnerabilities, the remote code exploits, and we know there's many, many vulnerabilities out there still. The Agent 11 I spoke about, that was 1.5 years ago. Guess how many of those devices have been patched?
Not many.
3%.
Wow.
So of the 2 billion devices.
After 1.5 years.
After 1.5 years, only 3% have been patched. And it really infuriates me in a way because we're not taking this seriously enough. And it's going to take another colonial attack. It's going to take another Irish hospital attack or a JBS or you name it in the past couple of weeks. And we need to have a wake-up call. And we need to get better to put our suppliers and ourselves more accountable for designing these devices more securely in the first place. Only then are we going to get to a better place. But we've been trying to do this now for how many decades? And it's
yeah, I was going to say we for those of us who've been around a little while, which I'll hold my hand up, we have been saying this, but the problem just seems to get bigger and bigger and bigger with the explosion of the endpoints in the network. I mean, the kind of weird thing is, if we think the problem's hard now, and it is it's way harder than it was 3 years ago, which was way harder than 5 years ago. But in 3 years' time, I mean, being a dedicated IoT company with 2,000 customers around the globe, several million devices under management, I mean, we say to customers, you ain't seen nothing yet. I mean, you got the 11 billion, 50 billion stat that I quoted, but there's this thing called massive IoT coming and 5G. Massive, it's expanding in 2 different ways. There's going to be sensors that use some form of cellular connectivity that are going to be disposable. They're going to be disposable. You can print the circuit, print the battery. There's going to be tracking on boxes, clothing, eventually, I don't know, a wrapper of a chocolate bar or something. But I have already had a big conversation today with a company that's looking at doing private, 5G networks, where you're talking about, tens of millions of things in a campus or in a large factory. So in other words, the numbers, the rate of adoption is accelerating. It's not linear, back to the exponential linear. And so even though at the very least, you can't put, if you said, what are the lessons from this? You can never, you never know what, if I was to summarize, nobody has a clue what's connected to their network, is what you've said.
Yep.
Secondly, you can't, even if you did have a clue, you can't put a piece of software on them because it's really old operating systems and there's too many derivatives. It's just there's not enough money in the world to solve that engineering problem because of all the permutations. So you can't put software. So So C, you need to use an agentless technique, which is what Armis is all about. You're the world leaders in that. D, even then, there's a whole bunch of devices that you can't see. Therefore, you've got to be able to see the devices that are really growing exponentially, which are the cellular connected devices, which is why you need to go through something like SI, which is the eye of the needle through which all the network traffic flows for all of those devices, regardless of the MNO. But then what we're saying as we get towards the end of the podcast is that, but even that's not enough, because ultimately it's just growing so fast that actually it's almost like we need to do something else that's not just technology. It's almost like we need to raise awareness right the way back to the start of the supply chain, because it seems like we're constantly, it's like the argument on the National Health Service is that no matter how much money you throw at the NHS, there's never enough. But actually, if you diverted some of it into disease prevention, from an ROI point of view, it's money better spent. But the disease prevention is almost like thinking about how devices are made by people who have no consequences of it, because they just make devices and sell them, and actually building security in and security considerations much more upfront than it seems to be that we're doing right now, because we're building these houses, if you like, with the windows open. It's not like people are thinking about that they have to do it. No one is really selling the fact that their devices can't be hacked. It's not the way we're selling things right now.
Yeah, there is a slight silver lining. So I do want to end on a slight positive note here. It's not all bad. Look, we do have the tools to help, at least now. But also, I think what we need to do is change organizationally how we think about this problem. And you started to mention it. The IT teams, the security teams have been moving slow together. They've really got to collaborate now. They've also got to extend their collaboration to the operational teams too, on the ground of the manufacturing centers, and bring them into the fold. And they've got to work with their R&D and suppliers as well, going as far back as possible to fundamentally understand what the risks coming into the organization are. And the good news is that there are models out there. There's the NEST model, there's the CMMC model that's being more adopted now. And I know things like the federal government here in the US is pushing all the suppliers to get to, you must be level 3 of this maturity model to do business. So we're moving in the right direction. Are we moving quick enough? Oh no. But we certainly need to solve organizationally how we think about the problem. We need to enhance our maturity of how we think about cybersecurity. And I think fundamentally we need to take, the human out of the loop. So going back to, as we engineer these problems, as we engineer the hardware and software, particularly the software elements, we're always going to, because we're flawed as humans, we're always going to put in vulnerabilities and exploits into the code. So if we can, and it's called shift left in the world of IT here, but if we can shift left and start to remove some of the human elements of doing bad things in the first place, to your analogy about prevention on the healthcare front, we can get to a better place. And there are lots of companies focusing on that part of it as well. DevOps, DevSecOps, call it what you will. It'd be great if we can build a machine that builds these machines that gets to the point where that machine is so clever, it doesn't have any exploits in there. But then you start to get into the big AI world of, okay, the overlords are going to take over. We will lose control, but it's a big old problem.
But in the meantime, what we're talking about here is such a order of magnitude improvement on what we're doing, because essentially what we're doing is we're using software techniques to recognize patterns of usage and normal behavior and identify anomalies across millions and tens of millions of devices, almost real time, and devices that are connected to somebody else's network, but ultimately they find a way of sending data to you. That in itself is mind-blowing compared to what, when you were in Symantec or when I was in Cisco, if somebody had said you'd be able to do this one day in the near future, we'd have said, I don't know what you're talking about. I mean, it just being able to do what you've described is mind-blowing compared to how we previously tried to solve these problems.
That's right. It's night and day. And the CIOs we speak to and the CISOs we speak to wants to understand what this can do and be a single source of truth for them and help them see everything. The shoulders start to drop, and it's a huge.
I can sleep at night. Yeah. Peter, that we probably leave it there on that high note. And wanted to just thank you. I would add that also for those people who do listen to this podcast, who are often in many cases, and we do get the messages, considering they're in the early stages of IoT projects, I think there's another lesson here, which is that you can add security and peace of mind in terms of central security policy deployed to cellular IoT devices at the edge to one of your checklists of things that you can look at, which will probably mean that your project is likely to get approved, because a lot of projects don't get approved because they get blocked for security concerns. So I think we've also made IoT adoption to be at least taken away one of the barriers or one of the main pushbacks that we get on projects, which is, no, it's not secure. I know this is a business outcome, but it's not secure, so I'm not going to do it. So I think that's a big improvement as well. So we'll leave it there. One last question to you. Though, if anybody listening to this wants to get in touch with you, what's the best way for them to perhaps send you a message or ask you a question? Maybe is it LinkedIn, or what's the best way they can?
You can certainly look at me on LinkedIn, Peter Doggart, and you can find me. I am the only Peter Doggart in cyber, so that's easy.
Okay, so that's Doggart.
That's right. Yeah.
Feel free to give me. Great. Well, thank you, Peter. Thank you again for your time. Very, very interesting. We haven't done a deep dive on security before, so that was really, really good. I suspect that in a year's time, we could probably repeat this and do a retrospective look back at some real case studies and stories, and then that would be really interesting to see what people are doing with this. So that's probably one of the goals of our alliance. But in the meantime, thank you to you, the listeners, for listening. This was as you know, the IoT Leaders podcast. If you want to send any feedback, you can send it to me, Nick Earl, on LinkedIn, or an email to iotleaders@si, that's ESEYE.com. In the meantime, thanks again. Look forward to the next podcast, and as I say, maybe an update on this very exciting area where we know there's a lot more to come in a few months' time as this a very exciting solution starts rolling out in the marketplace. In the meantime, thanks again, Peter. Thanks to you, the listeners, for listening. And this was the IoT Leaders podcast. Thanks very much and take care.
Thank you.